Oh my god, this is Kid. It's freezing. It's freezing in Hong Kong. It's freezing to me. It's 10 degrees Celsius here. I don't know if it's any kind of cold weather to you, but wow, I'm freezing. But has been busy days, busy weeks. So I haven't do any breakdown for quite a long time. But this is an SL paper, IBDP SL paper, 2012, many times on 2, paper 1. We're at number 9. It's basically a section B question. It's kind of a long question. It's a probability question. I don't do a lot of probability question. I don't really like it, but well, let's do one just for you. Okay, so we have a bag. Bag A contains 3 white balls, 4 red balls. 2 balls chosen without replacement. So pick it up, throw it away. Complete the following tree diagram. Do not write on this. Oh, okay, maybe not. Let's just write on this page. So draw a white ball. You have 1 less ball. You have 6 balls. You have 4 red balls. 4. Right. After red ball, you get 1 less red ball. Okay. 3 white balls. Okay. Just like that. You can see, right? Okay, so we fit the situation. 3 white, 4 green. Okay. Blah blah blah. Find the probability that 2 white balls are chosen. White ball means white. So you do this. You just need to know 2 things: multiplication and addition. Along the same branch, you multiply. So this is multiply. Across branches, you add them up. So 2 white, so white. 3 over 7 times 2 over 6. Do a little bit of simplification. 1 over 7. Bag B. What about bag B? Bag B contain 4 white balls and 3 red balls. 2 balls chosen at random without replacement. Again, the probability that they would be white is 2 over 7. Okay. So I don't need to do anything. A standard die is rolled. If 1 or 2 is obtained, 2 balls chosen without replacement. Otherwise, from B, find the probability that the 2 balls are white. So it looks like to be a good idea to draw tree diagrams here. I don't know you. It's particularly useful in IB because for more questions in IB, it's doable with tree diagrams. If you come from Hong Kong, you're doing Hong Kong DSC, I wouldn't recommend it. But it seems to be a good idea to do it at IB. So for the first branch, I may get a... When you throw a die, right? You throw a die. So this is the die. Okay. We get 1 or 2. So this is 1 or 2. And of course, this is 3 to 6. 3, 4, 5, 6. What is the probability with this? So we usually write the probability on top of the branch. So it's 2 over 6, which is 1 over 3. 2 over 3. And if I get 1 or 2, if 1 or 2 is obtained, I will draw it at bag A. I draw it from bag A. I need the probability that 2 balls are white. If I draw it from bag A, from the previous part, the probability of getting 2 white balls from bag A is 1 over 7. So it's 2 white is 1 over 7. So this is 2 white from bag A. Well, what about from bag B? If I get it from bag B, it says the probability of getting a white ball, 2 white balls, from bag B is 2 over 7. 2 over 7, I will get 2 white from bag B. Oh, okay, I feel warmer now doing this, heating up, you know. So what is the probability that I have 2 white balls? So along the same branch, we multiply across, we add them up. So 1 over 3 times 1 over 7 plus, because both of them will give you white ball. So you do this, or you do this, or you add. That's why across branch, you always add them up. So this is 1 over 21 plus 4 over 21, 5 over 21. C, part C. Given, so it's a given type, conditional type probability. Given that both balls are white, find the probability that is from bag A. How to do the given type? Given simply means your world shrink. So your world shrink from the chance that you can do the white ball you can do some non-white balls, to just some white ball. And so what is the probability that you get from bag A, right? So whenever you do given type probability, it would be a fraction. With denominator, the denominator is the probability of your shrink world. So now the world is shrink to just the case that both balls are white. So you need to think about what is the probability that both balls are white. And the numerator is the probability that they come from bag A. The they means the two white balls. So that what happened is on the numerator, you would need to get the probability that you get two white balls, okay, from bag A. This is how you handle conditional probability. It's almost like a formula. But I don't really want to write you the formula in symbols because I'm afraid you can't understand it. But the idea is the numerator is the probability of your shrink world, and above is the probability of the events that you want inside this world. So the probability of both of them being white is obtained in part B. So it's 5/21. And this, you need two white balls from bag A. So that's probability would be, I first have to go to bag A by throwing the dice, and then I get two white from A. So it's 1/3 times 1/7. Alright. Therefore the answer is 1/21 over 5/21. And if you know a little bit of how to do with fractions, this is 1/5. Okay? You may ask why is this 1/5? So let me talk about this quite quickly. Whenever you have a fraction that is more than 2 layers, so this particular one have 4 layers, 1, 2, 3, 4. You can always reduce it to 2 layers. So this is what you do. You recognize the bigger fraction line, so which is this one, and fraction means division. So divide 5/21. How do you do division of fraction? You flip the second one and change it to multiply. This cancel, so it's 1/5. Okay, 1/5. Quick way of doing this, you just flip this, you flip it up. Okay, flip this up, so it becomes 1/21 times 21/5. You flip it up. Okay, so remember this. That will help you quite a lot. So this is it. It's really typical probability tree math probability question for standard level. So of course the only difficult part would probably be the conditional part, where you need to understand what to do. Okay, I hope you understand. I hope you learned something. This is it.